Hello, and welcome back to a video series on MAT 1033 Intermediate Algebra. My name is Sean Perry. This is video number 50 in the series, Synthetic Division. So synthetic division is a kind of shorthand notation for polynomial long division. Coefficients in the polynomial control all of the numerical considerations in the division algorithm, except for the exponents, of course, but they really just tell us about what place we are looking at in the polynomial at a certain point in the algorithm. And what we're going to look at, rather than looking at the subtraction of term by term, we're going to look at the addition of the root instead. This will be sort of like adding negative rather than subtracting. This is most commonly used when we're only dividing by simple linear terms, something in the form x plus c, where for more complicated terms, it's usually better to use long division. And even though we're going to wind up using the same numbers as we do in the long division case, we'll wind up using fewer symbols overall with the synthetic division case, and so it'll be a bit shorter. Let's look at the method with an example. Let's take x cubed minus x squared plus 2x minus 1 and divide it by x plus 1. The first step in doing synthetic division is to record the coefficients in the dividend. Here we have 1x cubed minus x squared plus 2x minus 1. So we write down 1, minus 1, 2, and minus 1. Now the root of the divisor is the value which would make it 0. We're dividing by x plus 1, and this would be 0 when x is equal to minus 1. We set up a space similar to the quotient bracket to put our numbers into, something that looks a little like this: a box up top and a line. The root goes into this box. The coefficients of the dividend go here in a line. Leave a space above the bar, and we'll be writing above and below the bar. Now the first coefficient drops straight down. That will always be the case. Then we want to multiply this root by this number that we dropped down and write that product right here in the next column. Adding these two together, we get minus 2. Then we repeat. We take minus 1, multiply it by minus 2 to get positive 2, and adding these two together, we get 4. Last time, we take minus 1, we multiply it by this 4, we get minus 4, and adding these together, we get minus 5. Now we have to interpret our answer. These first numbers are going to be the coefficients of our quotient polynomial, and this final number is going to be our remainder. Since we began with a degree 3 polynomial, and we divided by a degree 1, our quotient is going to be a degree 2 polynomial. And we use this information to assign these numbers from our synthetic division into coefficients of a new polynomial. 1 minus 2 and 4 become 1x squared minus 2x plus 4, with a remainder minus 5, of course. And so this is our quotient and remainder. We could write this information down as our answer any number of ways, as we saw in the last videos. We could say x to the third minus x squared plus 2x minus 1 divided by x plus 1 is equal to x squared minus 2x plus 4, the quotient, minus 5, the remainder, over the original divisor x plus 1. Now, it's worth taking that same problem and looking at how that would look side by side with long division, just so we could see that really the same stuff is going on. There's a setup. We put this kind of setup for synthetic. We would do this kind of setup for long division. Notice that x plus 1 goes out front, while the root of x plus 1 goes here in synthetic division, and these coefficients in long division are here in synthetic division. Dropping this number straight down is the same as this number we've marked in our long division. Multiplying this out is expressing the idea that we're going to subtract, because this has changed the sign, and performing that subtraction. Here we perform this addition to get minus 2. Here we perform this subtraction and we get minus 2x squared, which is going to be the next term in quotient. And we can continue on in this way, making new numbers in either algorithm and comparing how they appear in synthetic versus long division. When we take a sum in synthetic division, we're winding up with a difference in our long division that encodes into the quotient. Once we push this all the way home, we're going to get our remainder. In either case, we wind up with a remainder of 5. So now let's look at some practical exercises. Use the above methodology to do each one of these divisions. Pause the video at this time and give it a shot. Okie dokie, let's see how you did. So the first step is to know that we're going to be divided by x plus 6, so we need to find its root, which is x minus 6. Then we encode the coefficients 1, 3, minus 2, and minus 5 into the following setup: 1, 3, minus 2, and minus 5. The 1 drops straight down. Minus 6 times this is minus 6. Adding these together, we get minus 3. Minus 6 times minus 3 is positive 18. Adding these together, we get 16. 16 times 6 is 96, and negative sign here makes this a negative. Adding these together, we get 101, and so that's our remainder, negative 101. To write that in the proper form, we can get this rational function to be this polynomial minus 101 over x plus 6. Notice we drop down from cube to a square, and then write these numbers as the coefficients of that polynomial. For the next one, we need to notice that we are dividing by x minus 2, and that this gives us a root of positive 2. And also we need to notice that this polynomial, x to the 4th minus 2x squared minus 2x minus 4, is missing an x cubed term. That has to be recorded with a 0, just like in long division, or we're going to get the wrong answer. Now we encode the root and the coefficients of our dividend and perform the algorithm. 1 drops down, 1 times 2 is 2, 2 plus 0 is 2, 2 times 2 is 4, 4 plus negative 2 is 2, 2 times 2 is 4, 4 plus 2 is 6, 6 times 2 is 12, 12 plus 4 is 16. We've reached the end, so this is our remainder, and this is our quotient. We went from a 4th degree down to a 3rd degree, so we write these numbers as the coefficients of a 3rd degree polynomial. And we could record that in the usual way, writing our quotient here, plus the remainder over the divisor. Last one, we're missing a linear term, so we need to put that as in the 0, and this x plus 1 has a root at x is equal to minus 1. Following the algorithm through, we drop this one down. 1 times minus 1 is minus 1. Sum them, minus 4. Minus 1 times minus 4 is 4. Add them together with this 2, that's a 6. Then we get minus 6, plus the 0 is minus 6. And finally, minus 1 times minus 6 is positive 6. Add them together, that's your remainder. We went from a 4th degree to a 3rd degree, so we drop this into the coefficients of a cubic polynomial, and we could express our answer this way. Oh, my bad, there was one more to do. So let's take a look at this one. Now the roots are something a little bit trickier. This is 3x plus 1. Where is that equal to 0? Well, solving, we get x is equal to minus 1/3. Taking these coefficients and writing them down, we get 3, 1, minus 12, and minus 4. And now we could still perform this synthetic division with a 1/3. Drop the 3 down, drop this down right as before, times minus 1/3 is negative 1. Adding these together, I get 0, and negative 1/3 times 0 is 0. Plus the negative 12, we get minus 12 here, and then times negative 1/3, we get 4. Add these two together, we get 0, and that's our remainder. Hey, we have 0 remainder. That means that we just factored this polynomial. This was a 3rd degree, so this becomes a 2nd degree down here. There are no x's, but there's a minus 12. So really we have 3x squared minus 12. And that actually is going to let us finish factoring this polynomial. We now know that x plus 1/3 times 3x squared minus 12 is equal to this cubic. But notice we could factor a 3 out of that last term and even put it back into the first term so that they had all whole numbers again. Then we get this factored version of the polynomial, 3x plus 1 times x squared minus 4. X squared minus 4 is a difference of squares. We could factor that out if we wanted to, but if we're really just interested in writing this as a quotient, then this cubic divided by this factor gives us x squared minus 4. This last example shows that even rational roots can work in synthetic division as long as you're careful with your results in the end. You can even do it with irrational and complex values, but this can become a little bit tricky. Unless you have a divisor in the form x plus c, I would recommend doing long division. If you have x plus c, then it makes sense to do synthetic division. If you have larger powers, or if you have irrational or complex or even rational roots, sometimes it's easier just to use long division. Deal with the extra symbols and the little tiny bit of extra time it takes to write them down in exchange for a lot less headache. Okay, that's it for this video. Thank you very much for your patience and have a great day. Good luck with your studies. I'll see you in the next one.